Okay, so we're looking at this paper towards robust mathematical reasoning, and it introduces something called IMO Bench. This seems aimed at really changing how we test the big AI models, right?
That's exactly it. It tackles a problem that, well, anyone following the field knows well: benchmark saturation.
Right. Things like GSM-8K for grade school math, or even math and AIM. Models are just getting too good at them, almost maxing them out.
Exactly. And the bigger issue maybe is that most benchmarks just check the final short answer. So a model could just get lucky or guess and get rewarded without actually showing solid reasoning.
Yeah, no way to tell if it actually understood the steps.
So the paper proposes IMO Bench. Think International Mathematical Olympiad level difficulty. Really tough, novel problems. And this was actually key for that Gemini Deep Think model hitting the IMO gold standard performance recently. Huge news.
A massive leap, yeah. And they're releasing this benchmark.
Yep, to the whole community. The idea is to push research away from just, getting the right number at the end and towards building AI that can truly reason in a way we can check and verify. That's the goal.
Okay, so IMO Bench has, what, 3 parts?
Three main parts. There's IMO-AnswerBench 400 problems, just get the answer. Then IMO-ProofBench 60 problems, where it has to write out the full proof. And finally, IMO-GradingBench, that's 1,000 human-graded proofs to help train automated graders.
Right, covering the answer, the reasoning, and evaluating the reasoning.
Yeah.
Makes sense. So let's dig into why IMO levels specifically. You said saturation, but what makes the IMO standard the right choice here?
Well, the IMO problems are notoriously difficult, but more than that, they're designed to require real novelty. You can't just plug numbers into a formula you've seen before.
So it forces generalization.
Precisely. It demands deep, multi-step thinking, often connecting ideas from different areas of math. If a model solves a new IMO problem, it suggests it's doing something more like genuine reasoning, not just recalling something from its massive training data set.
And the 3 parts you mentioned, AnswerBench, ProofBench, GradingBench, why break it down like that? Why not just jump straight to proof generation? Seems like the hardest part.
It is the hardest part, but think of it like building layers of evidence. AnswerBench is the baseline. Can it even get the final result? ProofBench is the core. Can it show its work convincingly? And GradingBench is almost meta. Can the AI or the tools we build with it even recognize good reasoning?
Okay, like different levels of scrutiny.
Exactly. It gives us a much more complete picture than just one type of test.
All right, let's unpack IMO AnswerBench first. 400 problems, 4 subjects, algebra, combinatorics, geometry, number theory, and different difficulty levels. You mentioned something crucial, robustification. What does that mean in practice?
Robustification is really key here. It's about taking existing problems maybe one's models might have seen in some form online and tweaking them. Experts carefully altered them to make sure the models have to reason through the problem, not just recognize it.
How do they tweak them?
Several ways, actually. Paraphrasing the wording, changing numbers, renaming things like points or shapes in geometry problems, or even reformulating the problem structure, sometimes adding extra information as distractors.
So it's like creating variations on a theme to check understanding.
Kind of, yeah. The paper gives a good example with an algebra problem from an Austrian Olympiad. The original asked to maximize x plus y plus z with some constraint.
Okay.
The robustified version used a clever substitution based on triangle side lengths, ABC, to essentially transform it into an equivalent but visually very different problem. A model has to understand the mathematical link, not just the original problem's text.
That's smart. It forces deeper understanding. Now, checking these short answers automatically, that has its own headaches, right? Like making sure the output is even readable or handling answers that look different but mean the same thing.
Oh, definitely. You might get an answer like all real numbers except not if of 4. Or you might get the interval notation like n infinity, NME4, U, N of 4, infinity. They mean the same thing.
So how do they handle that?
They built an AnswerAutoGrader using Gemini 2.5 Pro. It's designed to parse the output and, crucially, check for semantic equivalence using techniques like chain of thought prompting and checking its own work.
And how reliable is this autograder? Because, at the cutting edge, small errors matter.
They validated it against human expert grading, and it hit 98.9% accuracy on the correct answers. Which is pretty good, right? It seems reliable enough for this specific task of checking final answers across different difficulty.
Okay, reliable enough for the answers. But that brings us to the main event, really. IMO-ProofBench. This is where we move past just the answer.
Exactly. A right answer, as we said, could hide terrible reasoning. ProofBench forces the model to lay out its logical argument.
So 60 problems here. You mentioned a basic set and an advanced set.
Right. The basic set has 30 problems, mostly robustified versions of existing ones, up to medium IMO difficulty. But the advanced set, that's the real test.
Why is that?
It's 30 problems designed to mimic a full IMO exam, including really hard ones. And critically, it includes 18 completely novel problems created just for this benchmark by IMO medalists, plus tough recent ones from IMO 2024 and the US IMO 2025, also robustified.
Novel problems. That really tests generalization. And how are these proofs evaluated? Humans, I assume.
Yes, human experts using the standard IMO 7-point scale, 0 for basically nothing, 7 for perfect proof.
Okay.
For easier analysis, they group these scores into 4 buckets. Correct, 7 points, almost correct, 6 points, partial, 1 to 5 points, and incorrect, 0 points.
And they built an autograder for proofs, too, the ProofAutoGrader.
They did, also using Gemini 2.5 Pro, and this is a big, but the paper is very clear that this one is just a proxy. It's not a replacement for human grading.
Why only proxy?
Because evaluating mathematical proofs, especially the more informal, creative ones you see in competition, is incredibly complex. There's nuance, different valid approaches. It's hard for AI to capture all that reliably right now.
But does it at least correlate well with the human grades? Like, can it tell us which models are better overall?
It does correlate surprisingly well for ranking. They reported Pearson correlations of 0.96 for the basic set and 0.93 for the advanced set compared to human scores. So yeah, it's useful for seeing the relative performance of different models, even if it might misjudge an individual proof here or there.
Okay, let's get to those performance numbers then. This is where we see how the models actually did. On the IMO-AnswerBench, the short answer part.
Gemini Deep Think came out on top with 80.0%. That's nearly 7% ahead of the next best non-Gemini model, Grok 4, and over 19% better than the best open-weight model mentioned.
That's a solid lead. Did the results show any particular weaknesses?
Yeah, interestingly, across almost all models, the weakest area was combinatorics.
Why is that significant?
Combinatorics often requires more abstract thinking, finding clever mappings, using sophisticated counting arguments, spotting hidden structures. It's less about applying standard procedures like in, say, algebra. It suggests models still struggle with that kind of conceptual leap.
That makes sense. And did the robustification actually make a difference in scores?
Oh yes, they compared scores on original problems versus the robustified ones. Some models saw their performance drop by over 11%. It really shows that just changing the surface details forces the models to rely less on memory.
Validates the whole approach.
Yeah.
Okay, now for the ProofBench results. The hard part.
And it was hard. On the advanced set, most models outside the Gemini family scored below 25%, just couldn't really generate valid proofs.
Wow. And Gemini Deep Think.
It scored 65.7%. That's a massive 42.4% higher than the next best, which was Grok 4 Heavy at 23.3%.
42%. That's not just an incremental improvement. That's a different league.
It really suggests a qualitative difference in proof generation capability, or maybe the training data or methods used.
And this is where the overfitting question comes in, right? Looking deeper into those ProofBench scores.
Exactly. This is fascinating. Look at Grok 4 Heavy. On the USEO 2025 problems in the benchmark, which might have had some potential exposure in web data, it scored a really impressive 76.2%.
Okay, pretty good.
But on the novel problems, the ones created specifically for this benchmark, its score absolutely plummeted to just 11.1%.
Oof. That smells like overfitting or data contamination, doesn't it? It can handle stuff it might have seen, but falls apart on truly new challenges.
It strongly suggests that, yes. Compare that to Gemini Deep Think. It scored 69.0% on the USMO set and still managed 61.1% on the novel problems.
Much more consistent.
Right. The smaller drop suggests its capabilities are more general, more robust to novelty, which is exactly what IMO Bench is trying to measure. It seems better at actual reasoning, not just pattern matching stuff it's seen.
Okay, that brings us to the third leg, IMO-GradingBench. This tests if the model can evaluate proofs written by others.
Yep. It's given 1,000 proofs and has to classify them into those 4 categories.
Correct?
Almost partial incorrect.
How do models do there? Sounds hard.
It is very hard. The best accuracy any model got was only 54.0%. Gemini Deep Think had the best mean absolute error, meaning its mistakes were generally closer to the true category, but yeah, 54% accuracy. We're clearly a long way from reliable automated proof grading.
And even the ProofAutoGrader, which had high correlation for ranking, had issues. You mentioned specious errors.
Right. Despite the good correlation overall, the paper points out systematic ways it gets things wrong. Specious errors are like plausible-looking mistakes in the proof's logic that the autograder misses.
Can you give an example?
Sure. In one basic proof problem, PB-Basic 002, a model made a subtle but critical logical error high up in the proof. The autograder missed it completely and gave the flawed proof a high score.
Ah, so it can be fooled by sophisticated-looking flaws.
Exactly. But it can also be too harsh. In another problem, PB-Basic 027, a model provided a correct but unconventional proof. It missed one minor technical detail, so the autograder gave it 0 points. The human grader, though, saw the core correct idea and gave it 6 out of 7.
So it struggles with both subtle errors and unconventional correctness. That really highlights the limitations.
It does. The conclusion is pretty clear. The ProofAutoGrader is a useful tool for the community, especially for comparing models at scale. But you absolutely still need human experts for verifying individual results, especially high-stakes ones.
Okay, so wrapping up, IMO Bench really drives home that getting short answers isn't the same as robust reasoning, and even evaluating reasoning automatically is still a major hurdle.
Absolutely. It sets a new, much higher bar.
The authors themselves point out some big limitations going forward, right? For anyone wanting to use or build on this.
2 main ones. First, the cost. Real validation, especially for proofs, still needs those expensive, hard-to-find human experts. We need better, more reliable automated methods eventually.
And second,
Data contamination. It's the perennial benchmark problem. Now that IMO Bench is public, these problems will get scraped. They will end up in training sets. Over time, models might start memorizing them, leading back to the same saturation problem the benchmark was designed to solve.
yeah, how do you keep a benchmark challenging when the models are constantly learning from everything? That's a huge issue for the whole field.
It really is. It might require completely new ways of thinking about evaluation, maybe generating problems on the fly, or focusing even more on the process rather than just the final output.
So the big takeaway is the need to shift focus from just the answer to the process of reasoning, making it verifiable and robust. This benchmark gives us the tools to measure that.
Exactly. It shows where the frontier really is and
Yeah.
where the gaps remain, especially in those advanced proofs and in dealing with novelty like we saw with the overfitting results.
It definitely lays down a gauntlet. So for everyone listening, especially those working in AI research, the paper basically says, here's the new standard, here's where current models fall short, the benchmark is out there now. How would you design a system to really crack those advanced proof problems without just memorizing? That's the challenge IMO Bench leaves us with.